You're remote, you're using HAZ for a high precision location, and you need to take some spots underneath some dense foliage or a multipath environment. Let's talk about a neat trick to do it today. We'll be using two TX2s today. This one set up in base and another one in Rover mode. The base has been sitting out for about 10 or 15 minutes to get that HAZ convergence, that's high accuracy service broadcast over the Galileo network. That's a free correction service. And we'll be using the built-in ESP Now radios in every Spark PNT product to communicate between the base and the rover. High accuracy service from Galileo is great, but it is susceptible to something called multipath, meaning whenever you get near a building or in a high foliage area, we can lose accuracy quickly. To fix this, we use a base rover setup. The base, sitting out in the wide open with a PPP convergence, broadcasts the corrections over to a rover, so we maintain visibility as we approach our building over there with our rover. To set up this base, we allowed the device in rover mode to reach PPP convergence. That means it's sat here for 10 or 15 minutes, it's received the extra signal, and it's got precision down under that 20 centimeter mark. The next step was to put it into base assist mode. That's effectively saying, hey, I know you've got a point on the ground somewhere, immediately go into a fixed base mode with that location. Now again, it may be an inaccuracy of 20 centimeters, but it's pretty good. Additionally, we've got it broadcasting those corrections over its internal ESP Now radio to our rover. Now our rover has a nice RTK fix, and now we can take the rover wherever we need to go in a bad multipath environment. So we've got our rover with an RTK fix up against this multipath environment. We've got various faces of the SparkFun building that are going to be bouncing signals around, causing issues. Currently, we've got an RTK fix, a nice RTK fix. We can see that even as we approach the building and need to take dots, we've got a 2 centimeter accuracy, which is kind of reflective of our base out in the field with that HAZ correction. So to demonstrate what it would be like without our base rover setup, we've stood out in the parking lot and gotten our PPP convergence on our HAZ signal, and things are going well. We've got about 15 centimeters worth of accuracy. Now we're going to demonstrate just when HAZ starts to disappear in that multipath environment. So we're going to try to get first to where we were before. We've still got our PPP convergence, and now we're going to approach the wall, see what happens. And there we can see we quickly lose accuracy. We're already up to 40 centimeters, and we'll quickly lose RTK fix here. If you find yourself in a dense foliage area or a kind of a multipath environment and you need to get some high precision locations without the ability to connect to the internet, consider using HAZ in a base rover setup.